Okay, so for part 2 of our lesson on trig values, why are they positive or negative? And your job is to explain why some trig values are positive and why some are negative. Yesterday, we reminded ourselves what the degrees on a coordinate plane look like and what radians look like. And then we went through and, sorry, this is empty. It was there before, but I had to erase it for today's lesson. Excuse me. Here I am eating an apple on video. It's probably not good. I'll stop. Okay. So we found that when we put a reference angle, an angle beta, right, in quadrant 1, a reference angle in quadrant 1, we found that our adjacent side was positive, our opposite side was positive, and our hypotenuse was positive. Therefore, all of the trig functions were positive in quadrant 1. So if your terminal side is in quadrant 1, your trig functions should all be positive. In quadrant 2, we learned that only sine was positive. However, cosecant, which is the reciprocal of sine, is also positive. Okay, so sine and cosecant. In quadrant 3, terminal sides in quadrant 3, we learned that tangent and its reciprocal cotangent were positive, but sine and cosine were negative. And then I sent you home to figure out what happened in quadrant 4. If your terminal side is in quadrant 4, you had a positive, here's your angle beta, your reference angle. You had a positive adjacent, a negative opposite, and a positive hypotenuse. So your sine, which was negative over positive, so your sine of beta was negative. Negative divided by positive is negative. Cosine, however, you had a positive opposite and a positive hypotenuse. Positive divided by positive is a positive cosine of beta, and they're equivalent. And then your tangent, which is your opposite, which is negative, over your adjacent, which is positive, is a negative tangent beta. So that should have been what you did to finish up your notes for that problem for last night. And so here's what we found, and it wasn't tangent, that cosine is positive in quadrant 4. And also secant, which is its reciprocal function, is positive. So there's a little mnemonic that we use to help us remember, and I'm not sure if I spelled that right. Mnemonic. Something like that. Might have an E in it somewhere. Okay, but you know what I mean, right? So where are the positive values? Because if we know where the positive values are, we can assume where the negative values are. It goes like this. A smart trig class. So what it means in quadrant 1 is that all the functions are positive. And in quadrant 2, sine and cosecant, which is its reciprocal function, are positive. In quadrant 3, tangent is positive and its reciprocal function, cotangent, is also positive. And in quadrant 4, cosine is positive and secant, which is its reciprocal function, is positive. So if you can remember in a positive rotation, a smart trig class, breaking your quadrants up, that will help you to remember which functions are positive in each quadrant. So let's do a practice problem. So we're going to do a little problem here. So here's the instructions. Hang on a second. I forgot how I wanted to word it. I'm almost there. Here it is. Find the exact values of the 6 trig functions of theta if theta is in standard position and P, capital P for point, is on the terminal side. And I'm going to give you a value. P is at -3, -4. So, digest that. Think about that. I want to know all the trig values. What would you do to maybe start to come up with a plan? What's your plan? What would you do, Isaac?
Kind of like imagine it on the plane. The first one would be the adjacent, and the second one, the y would be the opposite.
So you're saying the x is your adjacent side of theta, and the y is your opposite side of theta. And so you would throw it on a graph. So you'd go -3, -4, and graph that. And so we're talking about angle theta here, which is in standard position, and it's passing through this point right here on the terminal side. So this is massive reflexive angle right here. But we're, of course, going to use its reference angle, right? And so we're just going to go down the terminal and then vertically to the x-axis to create our right triangle so we can find our trig functions. We need a right triangle to do that. So angle beta is here. And so you're telling me that the adjacent is -3, right? And the opposite is -4, correct? That's what you're telling me, because that's where that point is, -3, -4. Beautiful. Okay, so now here's one thing I know. I have opposite and I have adjacent. That means I can tell what tangent is right now, right? Right? So tangent of theta, which, by the way, should be positive or negative. I'm in quadrant 3. Positive is opposite over adjacent. So -4 over -3 is 4/3, which then in turn I can find cotangent right away, 3/4. So I know that I've got 2 of my functions completed. What could I do to find cosine and sine? Because I need a hypotenuse to do either of those values. What strategy would you use? Pythagorean theorem. I think that would be great. I also think it's really important to remember that if the sides are 3 and 4, the hypotenuse is 5. But you, of course, could use the Pythagorean theorem to determine that that's true. But you need to remember that 3, 4, 5 is a Pythagorean triple. So, and remember that hypotenuse is always positive. Okay, so what's our sine? Sine should be positive or negative if I'm in quadrant 3. Negative. So it's opposite, which is -4 over hypotenuse, which is 5. And then it's cosecant, which is your reciprocal function, -5 over 4. It's just a negative fraction. Cosine of theta, adjacent over hypotenuse, -3/5. Secant, which is your reciprocal, -5/3. And there you have it. This was a skill that I asked you to practice work on your test the other day. However, we were just working with right triangles. Now we're graphing right triangles on a coordinate plane and we're introducing negative. But it's the same strategies that you've already practiced. Questions about that? Okay, I'm giving you 4 problems in homework that are just like that. So there's an example of how to do problems 67 through 70. Now, I would like to talk to you about these problems. The instructions say, approximate the value of the trig function to 4 decimal places and explain or illustrate why the value is positive or negative. Let me just say something that I think you should all listen to. When you're taking a trigonometry class, it's like taking a geometry class. You need to draw the picture. Draw the visual representation. Get out your graphing calculator. Graph it. Just get a visual as often as possible, because that's the thing that's going to help you understand why things happen in trig, and it'll help you to understand trig on a whole. So let's take a look at this problem. We are asked to approximate the value. So I'm not asking for the exact value. I'm just asking for the approximate value to 4 decimal places. First, I would like you to actually draw a picture. So this is the secant of 55 degrees. So really important that you can tell me what quadrant that angle's terminal side lies in. Quadrant 1. So there's your terminal side at 0 degrees, and we'll rotate up about 55 degrees, right? So there it is. So I'm not going to ask you to, that's an acute angle, so you don't need a reference angle. I'm not asking you to draw a triangle. I just want you to tell me, is secant positive in quadrant 1? So we're going to say, okay, so secant is positive. That's all I'm looking for. Can you draw the terminal side in the proper quadrant? And can you tell me if the function's supposed to be positive or negative? That's it for your illustration. If you want to illustrate it. If you want to explain it in another way, then of course you figure out how you'd like to do that. Now let's actually use our calculators. What's really important to note here is that your calculator needs to be in degrees, because this is the secant of 55 degrees. If it's 55 radians, this would be a huge angle, like spinning around whatever 55 divided by 6.28 is, a lot of times, 8 or 9. Okay, so how am I going to plug this into my calculator? My calculator has to be in degree mode, and your calculators might be in radian right now, so you need to check your mode. Okay, how are you going to type this in? You don't have a secant button. Yep, you're going to write it as 1 over cosine of 55, because you need to use your reciprocal function, cosine. So 1 over cosine of 55, it better be positive. 1.7, 4 decimal places it says. 17434. All right, beautiful. And it's positive, right? All right, makes sense. Let's look at the next one. Tangent of 132. So first, again, my advice is draw it. So where is its terminal side? Where does the terminal side lie? 132 degrees. Here's 90. Here's 180. So it's definitely over here somewhere in quadrant 2. So tell me what you know about tangent functions in quadrant 2. They're negative. Okay, so tangents are negative, so my answer should be negative. This is a great test sometimes to know if you're in radians or degrees, because you know it's supposed to be negative, but if your calculator's in radians, it might give you a positive answer. So look out. All you got to do is type it in. You don't have to find the reference angle for the calculator. The calculator will find tangent of pretty much any degree you want it to find. What do we get? 1.1106. Negative, for sure, right? All right, so there's that. Last one, cosecant of negative 81. So if I need to be able to draw that. So here's my initial side. Negative 81 degrees is a rotation up or down? Down, right? So where's my terminal side going to lie? Quadrant 4, right? Almost to negative 90, almost. So here's what I know about cosecant. Be careful. This is cosecant, not cosine. Cosecant's the reciprocal of sine, so that means your answer should be negative. Okay, so how are we going to plug this in the calculator? 1 over sine of negative 81, which is approximately 0.125,4. Thank you. Okay, so that's not difficult. This is what I'm asking from you today. Okay, let's go on to the back side then and practice doing some with radians instead of degrees. So super important that you look at these problems and you recognize that there's no degree symbol. None. Therefore, these are radians, right? So you need to make sure you change the mode. Change the calculator mode. Okay? All right. So cotangent of pi over 12. Well, I want an illustration. Where is that? Let me remind you what we talked about. Excuse me. What we talked about yesterday. In radians, we know in a full revolution, there are 2 pi radians. So we have 0, and we have pi over half, pi, and 3 pi over 2. So those are our radians. Okay. I also asked you to convert them to decimals because sometimes we understand decimals better than we do pi. So pi divided by 2 is 1.57. Pi is 3.14. 3 pi over 2 is 4.71. And 2 pi is 6.28. Sometimes it's useful to change things to decimal. Some people can see that cotangent of pi over 12 will have a terminal side in quadrant 1 because it's pi, which is 180 degrees, divided by 12, right? So that means I'd have to put 12 slices in the top half of my coordinate plane. But if you change it to a decimal, just quickly divide for me, please. Pi over 12, which is also approximately, give me 4 decimal places. 0.2618 or 7. Okay, so that's a pretty small radian, right? 0.2618 radians, and that's definitely between 0 and 1.5. It's really small. So when I go to draw my angle here, my terminal side is definitely in quadrant 1. And what do we know about cotangent in quadrant 1? It's positive. Everything's positive in quadrant 1. Okay, so now we just have to plug this into the calculator. So we're going to type in 1 over tangent of pi over 12. And we get the answer. What? Okay, so I want the decimal answer to 4 decimal places. Convert. 7320 is correct. Okay. Now, here's my concern. I want you to be really careful. The cotangent of pi over 12 does not equal the tangent of 12 over pi. I want you to make sure you understand that. That's not a true statement. Tangent of 12 divided by pi, that's a big angle. That's a big angle. Okay? So don't reciprocate the radians. It's the trig value that flips, not the angle measure. That doesn't flip. So be really careful with that. You have to do 1 over tangent of pi over 12 to get the correct answer. All right, let's go to cosine of 3 radians. P.S. What's the difference here? If this was 3 degrees, where would my terminal side lie if this was 3 degrees?
Yeah.
It would be this tiny little thing right here, right? But 3 radians, that's not it. That would be a really big mistake. This does not say 3 degrees. It says 3 radians. Well, 3 radians is like right here. Really close to pi, right? Pi is 3.14. So 3 radians is pretty big. Really large reflexive. What do we know about cosine in quadrant 2? It's negative. So when we type it in the calculator, we should be getting a negative answer, and we get negative. I'm thinking it's going to be almost 1 because the cosine of pi is negative 1. So I'm thinking this is almost negative 1. 0.9900. Yeah, it's almost negative 1. Almost. Okay, last one. Here we go. Sine of negative 0.15 radians. So where does my terminal side lie? I have to rotate downwards, right? And that's not very big, right? Here's 0. Here's negative 1.57. So it's right here somewhere. And what do we know about sine in quadrant 4? It's negative. So that means my answer should be negative. Plug it into your calculator. Sine of negative 0.15. 1494. And this is what I'm asking you to do for homework or for your assignment today. Now you have 25 minutes left of class. So I'm thinking if you buckle down, you could get the assignment done. But before I stop the video, do you have any questions? Remember my advice. Draw the picture. Well, the instructions